Hello and welcome to Beta Things. I'm here at our new top secret laboratory studio in Merville, BC on Vancouver Island. Welcome to Beta Things! Hello, I would be Paul Myers, and welcome again to Beta Things. Today, we're going to talk about a piece that was inspired by, forgetting his name already, Mr. David Roy. If you look up wood kinetic sculptures anywhere on Google, this guy's going to come up. He makes these cool sort of reality distorting movements that fit on walls, and they're all out of wood. I will pull one up so you can see here. So there's a lot of people that are sort of copying his work, and you can find mimicking pieces on YouTube or on Etsy and stuff like that. But I thought I would bring these movements to your desktop. So I kind of reverse engineered a little bit, created a bit of my own mechanism to make it work, and that is what we're going to be talking about today. So I did 3 prototypes this time. One is, as I've said in the past, my destructive testing. This is my first prototype. Or actually, no, this is parts of this are the second. Oh, it's just a mess when you prototype something. The first full sort of pieced together piece I had was this, with an experimental belt drive system where we're translating from this axis to this axis with both the plates having to go in opposite directions, so the elastic bands cross over, and it works for a quick second, you know, like, see? But the elastic bands end up crossing and falling off. I might be able to save this one by like increasing the size of these edges to keep the bands in place, but I still think that this cross thing is gonna get away from me. But yeah, so that was the first idea. I wanted to make a little business card holder for your desk that you could like hypnotize your clients with, you know? And so when that one came off the bed and I put it together and it didn't work, I was really upset and I was almost ready to give up. But then some of you that follow me on Instagram, Beta Things with a Z, you would have seen this picture. And this was sort of my saving grace for this movement. I needed to turn a single crank movement into 2 different rotations on the same axis, and that's what this sort of came to. It looks a lot kind of like a car differential, and it's kind of the way a car differential works, really. If you lift the back end or whatever drive, front or back end, off the ground and hit the engine, the wheels are going to spin in opposite directions. The only difference here is that rather than having a wheel on both sides, this back cog actually sends a shaft through the front one, completely independent of the front one, so it manages one disc and then the front cog manages the other disc. And you'll see that in my model. Oops, getting ready here, getting better at this live editing thing. Oh, and he's signed out. How professional. Here we are. So yeah, this is the 3D model of what I was talking about there. You've got your input crankshaft here, and it in turn meshes with the front and back cogs and forces them to turn in opposite directions. So the shaft coming out of the back cog goes through the front cog and to the front plate here, and of course the front cog just is attached to the back plate. And so we get a nice spinning movement. Everything's all synchro meshed together. So let's take a look at the Showoff clip. So I think I should be able to talk over this. This print, it took a few tries to get. There's a lot of sort of weak areas, especially in the shafts. Basically, everything but the main body had to be printed at 100% infill just for strength. You can see there the movement is actually messing with the refresh rate on my camera. It's kind of glitching out, but it has a really cool look to it in person. You can spend hours just spinning the thing. The gears are really fun too, so I really like making this one. And so yeah, that is going to be coming to a 3D printer near you soon. It'll be up on Thingiverse. The link will be in the description of this video, but we're doing something a bit different. I'm not going to give you the straight files. I am going to put physical locks in the STL that you'll be able to download. And I'll also include source files for, say, SolidWorks, and maybe a link to my Onshape account so that you can grab it there. The point is that I'm trying to promote engineering, and if people really like these geared things and they really want to have them, then maybe they'll take the time to learn how to use the tools and unlock these puzzles, basically, that I'm creating, and then download the file and print it off for themselves. So it'll be kind of like a badge of honor. For this first one, I'll probably do 3 physical locks, and these will be anything from gears that are connected to each other in some way, to changing an object to make it unprintable, so that you'll have to remove or add something in order to make it printable. And I think for this one, I'll probably point out exactly what the 3 things are that need to be changed to make the object work. Maybe in future, we'll do sort of mystery puzzle objects where you'll have to figure out what's wrong with it and sort of engineer your way through the object and get it to the point where it's working. I think it'll be a lot of fun. And if everyone gets stuck, maybe I'll do a tutorial on how to unlock your objects. But yeah, that's the new things from Beta Things. I hope you enjoy. Coming soon. I haven't named it yet. I don't know what to call it. It's basically someone else's idea that I just made work a different way. But I like it. I really like gears. Gears are my thing. But yeah, that's it for this week. Coming up next time, hopefully, will be the marble lock, which will be a lock for your door that uses a specific size of marble to open it. And then, when you're done using the marble as your key to open your door, it's going to eject that marble out the handle and into the palm of your hand. Like freaking magic. And it's going to be great. So look forward to that next time. In the meantime, I've been Paul Myers. Thanks for watching Beta Things. I'll see you next time.